It is saying the giving the answer of the movement of the P wave. As I have told you, because of their movement, the P waves, how they travel, that's what making them faster. So P waves are compression waves that apply a force in the direction of propagation and transmit their energy quite easily through the medium. So these are applying the force there itself on the propagation direction. So that will increase their speed more and more. And that way, ultimately, there would be increase in the travel energy or speed there. So on the other hand, S waves are transverse waves or the shear waves, which will move like this. The movement in the water of the waves here you can see. So motion of the medium here is perpendicular. So this is the motion of the medium here you can see. By this way, this is moving, sometime going up, sometime going down. And this is the movement. So here you can see the motion of the medium is perpendicular to the direction of propagation of the wave, hence less easily transmitted through the medium as compared to the P waves. So the movement direction helps the P waves to move faster as compared to the S waves. So this is the concept behind the faster speed of the P waves. As I have told you, P waves also act as an earthquake warning. Advanced earthquake warning is possible by detecting the non-destructive primary waves that travel more quickly through the earth crust than do the destructive secondary and the surface waves. Then, depending on the depth of focus of the earthquake, the delay between the arrival of the P waves and other destructive waves could be up to about 60 to 90 seconds. Depends on depth of the focus. So at least 60 seconds we will have. In the 60 seconds, quickly you have to announce all over the building area, density populated area, come out from all the buildings immediately because earthquake is going to come. So that kind of warning system is installed in the earthquake prone area in countries like Japan. So in Japan, there are big sirens. Those sirens are used to play whenever there would be earthquake warning or tsunami warning. Immediately, you have to come out from the buildings for the earthquake warning. So that will immediately, in the detection of the P waves, these are totally uh, quickly announced to just play the sirens, and the peoples are aware 60 seconds to 90 seconds prior to the earthquake happening. So P waves are also act as a warning sign of the earthquake. So I hope this is clear to you. Now secondary waves. This is the detail about the secondary waves. Secondary, they are recorded second on the seismograph, or their arriving time is second after the primary waves. Or S waves are also called as the transverse waves or shear waves or distortional waves. They are analogous to water ripples or light waves, as I have told you. The movement is like this. So, like the water ripple or like the water wave. Light waves similarly travel in the same way. So, these are called as the transverse waves or shear waves or distortional waves because of the movement nature. Transverse waves or shear waves mean that the direction of vibration of the particle in the medium is. This is the direction of the movement of medium. While the direction movement is perpendicular to this particular medium. Here you can see. So that way, this is also called as transverse waves or shear waves. Hence, they create troughs and crests. This is the trough, this is the crest, this is crest, this is trough. So in the trough and crest formation, there is taking place here through the which they pass. So they distort the medium. That's why these are called as distortional waves or transverse waves or shear waves. So the S waves arrives at the surface after the P waves that I have already told you. These waves are of high frequency and possess slightly higher destructive power compared to the P waves. Still, these are very, very less destructive, but if you compare it with the P waves, so these are more destructive than the P waves. These are the S waves. The trembling on the Earth's surface caused due to these waves in from side to side or horizontal movement. So because movement is like this, so there would be trembling. Suppose this is the Earth's surface, and here if it is moving, so it will create trembling of the Earth's surface in the horizontal direction. So that will create a destruction in the Earth's surface. because these waves are moving from side to side or in the horizontal direction. S waves cannot pass through the fluids, liquids, or gases, as fluids do not support the shear stresses for the S waves movement. So, on that way, S waves are not that much destructive as compared to the previously upcoming waves, surface waves, you can say. They travel at varying velocity proportional to the shear strength. Higher would be the shear strength, higher would be the velocity through the solid part of the earth. So this is all about the secondary wave. Now, after that, primary waves, secondary waves, it means body waves we have covered. Now we have to start the surface waves. Surface waves are also called as L waves. Then, these are the most important waves in the formation of the earthquake. The body waves interact with the surface rocks and generate new set of waves. So these waves are created by the interaction of the primary wave with the surface rock. These are called as long or L waves. For the L for long, so that's why these are called as the long or L waves. These waves move only along the surface of the earth, as I have told you. Surface waves are also called long period waves because of their long wavelength. The wavelength is very, very high in the case of surface waves. They are low frequency transverse waves or shear waves. It means low frequency of secondary wave is called as the L wave or the surface wave. They develop in the immediate neighborhood of the epicenter and affect only the surface of the earth and die out at very smaller depth. So just side of the epicenter, these waves are generated and affect only the surface of the earth and out of to very smaller depth also. They lose energy more slowly with distance than the body waves because they travel only across the surface, unlike the body waves which travel in all directions. So loss of energy is also less here as compared to the primary and secondary wave. Particle motion of the surface waves amplitude is larger than that of the body waves. So surface waves are the most destructive among the earthquake waves that we already explained here. They are slowest among the earthquake waves and are recorded last on any seismograph. So, again, these different waves are divided in two categories. One category is love waves, another category is the Rayleigh waves. Love waves are the fastest surface wave and moves the ground from side to side. So, ground will move like this. Suppose this is the Earth's surface. So, the movement of the surface like this. Then we have the Rayleigh waves. Rayleigh waves rolls along the ground just like a wave rolls. This will just up and down movement would be there in the surface of the earth like this. And side to side in the same direction that wave is moving. So up and down as well as side to side movement. Most of the shaking and damage from the earthquake is due to the Rayleigh wave. In the comparison of this love waves and Rayleigh waves, highest destruction is caused by the Rayleigh wave, and then second is the love waves, then third is the S waves, and no destruction caused by the P waves. So I hope this thing is clear to you all. Here you can see this is the same video for that I have told you to watch the video in the YouTube. So this is the movement of the P waves. Here you can see the contraction and the rarefaction would be there. And such a way this wave like move in the upper direction. These are the surface waves. Here you can see no impact on the surface because of the movement on the body itself. So this is creating waves on the longitudinal body of the Earth's surface. Then we have the surface waves. So in the surface waves, here you can see this is the love waves. So such type of movement is caused in the surface waves. So similarly here, this is going this side, coming this side, and again going this side, this side. Such kind of movement is found in the love waves. Then we have the Rayleigh waves, which is clear. You can see here movement like the ripples in the water. So that is such type of. crest and troughs are formed here, so which will cause highest destruction in the form of secondary waves. So hope this is clear to you. The next thing that we have to cover in this topic is how do seismic waves help in understanding the Earth's interior. Seismic waves get recorded in seismographs located at far off locations. These multiple seismographs are installed all over the region. Differences in arrival times, waves taking different paths than expected due to reflection and absence of the seismic waves in certain region called as shadow zone allow mapping of the Earth interior. Now, what is the meaning of this? Suppose this is the Earth, and in the surface of the Earth, we have multiple seismographs installed all over the world to record this earthquake coming on the different part of the Earth. Then some portion or some seismograph will record the earthquake. Suppose this is the generation point or the focus of the earthquake, and this is the epicenter. So now here the seismograph will record on some area, but some areas of the seismograph not record this particular wave. So that's why these are called as the shadow zones of the earthquake. So now why this is happening and why it is important to understand the earth interior, that we will see here. So discontinuities in the velocity as a function of depth are indicative of changes in composition and density of the waves. So that's why some are recording the earthquake, some are not recording the earthquake waves. That is, by observing the changes in velocity, the density and composition of the Earth interior can be estimated. Higher is the velocity, it means higher is the density at that place. Lower is the velocity, or maybe absence of the earthquake will lead to tell you there is a liquid portion present inside the earth surface. That's why, because we have seen that the secondary waves cannot pass through the liquid. So if suppose magma is present below the earth surface, so that magma layer is liquid. So that magma layer cannot be crossed by the secondary waves, and that way we can understand that the this portion of the Earth's surface is made up of the magma because S waves cannot cross that. Then the difference in the speed of the P waves is also because of the change in the shear strength or change in the liquid and solid proportion of the different materials there. So by that way also we can understand that how P wave is changing its velocity due to the different types of form or composition of the materials inside the earth. But discontinuities in wave motion as a function of depth are indicative of changes in phase there. Changes in liquid phase and again solid phase, again maybe liquid phase. So that is telling something to you that by this way, by this speed is due to the solid portion, and this speed is due to the liquid portion. That is by observing the change in the direction of the wave, the emergence of shadow zones, different layers can be identified inside of the Earth's surface. So let's look at the photograph of the shadow zones of P waves and S waves. Before going to that, you should understand that S waves do not travel through the liquid. They are attenuated there because we have already seen that S waves are not capable of moving through the liquid. Here you can see this is the shadow zones of the S waves. So here you can see this is the focus of this particular earthquake. The primary waves are moving like this. And here you can see there is a sudden liquid formation here just above the core. Now from this particular liquid zone, the P waves can travel, but S waves cannot travel. So by that way, this is the total S wave shadow zone. In this zone, there would be no detection of the S waves because of the liquid portion present just beneath the core. So 103 degree to 103 degree. This is called as the S wave shadow zone. So I hope S wave shadow zone is clear to you. Similarly, we have the P wave shadow zone here. Here you can see that P waves are moving like this. And here, because of the presence of liquid material here, the P wave ray paths are distorted here, you can see. So this can be found up to the 103 degree. Then inside the core, because inner core is totally solid, so it can pass the core easily. But the reflection would be there, similar to the light ray or light wave. We can see similar kind of reflection we can see here in the P wave, and then again P waves can be received here from the 142 in the opposite side of the earth. So here the shadow zone for the P waves is only from 103 to 142, while the 103 to 103 is the shadow zone for the S wave. This is the shadow zone for the P wave in both sides, not in single. So that you have to remember while you are talking about the shadow zones of S waves and P waves.